Hello, students. As you've noticed, I am out. I'm away on an engineering field trip to UNR. It's possible I might be back during this period, and if I am, I'd really love to see you working on this stuff. It's going to be a little problematic as you begin because a lot of you ninth graders were absent on Monday because of what was that thing that you went to? I don't even know what it was, but you were gone, and that means that we got to sort of back up, and you're going to have to do a few things to yourself. So the first thing I'm going to do is talk about where the other classes are. So on the block day today, you have an objective. It's to create a design brief for the Automoblocks enhancement project or problem, and to begin brainstorming and making sketches for enhancement ideas. What's this thing about a design brief? That's really important. And those resources were posted on the day that you were absent, right? Or the day on Monday. So let's take a look at what's there, and then I'll show you an example of a design brief. If I pull this up, it's a Project Lead the Way slideshow. And if I go through and present, I'm not going to show it all to you, but it is in front of you so you can look at it. The first part is writing a problem statement. So really, I think the most useful part is what belongs in a problem statement. It should be short. The problem statement should not have any part of the solution in it. It doesn't tell us how we're going to solve the problem. It's just clearly and being specific to define the problem. These are the things that belong in a problem statement. So you may need to come back to this slide to write a proper problem statement. Here's an example, right? They say game fishermen fishing in the lower Laguna Madre of Texas reported between 2002 and 2007 a decrease of 20% in red drum. I'm assuming that's a fish. This loss can be attributed to premature death due to the mouth infections caused when undersized fish are caught and released. So there's a lot of information in there, right? What does it tell us? It tells us, let's see if I can get that off there. Can I move this guy? It tells us who, what, where, when, and how many. So a problem statement has got to have those pieces of information on it. And remember, those pieces are on here, right? You also then need to know, okay, once we've defined the problem, what are the criteria for our solution? What do we want our solution to involve? And what are the limits or the constraints of our solution? And that's on this slide. And again, it's a long slideshow with a lot of detail. I'm just going to show you some places to get started on this. So the first thing, if I go to the second one, I go to the second here, and it's saying these are things we might need to consider when we're thinking about what the solution should look like. Does the performance of it matter, or is it just important to look a certain way? Does the size and shape of the solution matter? Aesthetics, is how it looks important? The materials, can it only be made of certain materials, or are the materials going to be part of the criteria? Are there safety and legal issues? Ergonomics, is it easy for a human being to use? Does it conform to the body's shape or the way that we work? Are there environmental factors? Is the life cycle of this going to be important? Are we making something disposable, or are we making something that's supposed to last? And is it going to require maintenance? So we're thinking about whether these things should go into the design constraints. And we'll take a look at criteria. We'll take a look at an example, like I said. So these are criteria. What do we want our solution to have in it? But it's not telling us about individual solutions. And the next slides give us an example of what that looks like, right? And it goes through, what does it mean to have a performance to be a criteria, product size and shape, aesthetics, so on and so forth. And I'll let you look at those. So the other slide I'm going to go to is the design constraints. So the constraints are things that limit us. Is the sky the limit for us? Do we have an unlimited budget? Can we use any imaginable material? Probably not. So the constraints are these: the limits on the design of the production. So the resources: who's doing it? What people are working on it? What equipment do you have? What budget is available? Is there a time constraint? Are we going to try to make this thing in a year, or do we need to try to make this thing in the next couple days? Is energy an issue? Is this something that we're going to have to sort of build a new building and bring new energy into? Is it going to require batteries or generators or something? Materials. Are we limited to just using a few materials, or can we pick any material to make our solution out of? And the process of manufacturing. And maybe there's some other ones. And again, there's a little bit more information under there. So what do I want you to do? Let's look at an example of a decently made constraint, and that comes from Project Lead the Way. So this is 7.6. In class, we watched an Apollo 13 video and applied it, but a lot of you missed that, so we're going to look at an example. Here's the design brief example. It says ABC Toy Company, that's the client, and the target consumer in this case is the parents or the purchasers and infants and toddlers who are going to be users of the project. It says the problem is here. Now they're going to identify a lot of things. Most parents expect their children, so that's the who, to be able to walk, talk, sing, count, and recite their ABCs before they enter elementary school. That's the problem, right? How do we help that happen? A growing demand is placed on infants and toddlers to develop their cognitive abilities and fine motor skills during the first 3 years of life. So if I go back to that problem writing thing, all of these or many of these things are included in that problem statement. A good problem statement should have that in there. Let's take a look at a little bit more of it. So then what's the design statement? This part is lacking in the slideshow, but you can make your own. It's pretty simple. It says, design, market, mass produce a multi-use educational toy that serves as an infant activity center and a toddler's walking aid. So it's basically saying, here's our problem. Here's what we're going to design to try to solve the problem, or what the design might look like. It's not specific yet, but it's saying this is what we want to do to address this problem. Here we'll see then, here's the criteria. It's got to be safe, easy to assemble, visually stimulating, contain multiple shapes, plays music, meets health and safety codes, easy to clean, easy to transform between infant and toddlers, less than 4 pounds, under 20 bucks. Design constraint, it's got to be completed in 1 week, and the parts made primarily from injection molding. So as simple as this small document is, that's a good design brief, and that's the first thing I want you to work on today for your AutomoBlocks enhancement project. That's going to be the second video.